The Owyhee volcanism was due to the Yellowstone hotspot, also referred to as the Snake River Plain Yellowstone hotspot, and is a volcanic hotspot responsible for large-scale volcanism in Oregon, Nevada, Idaho, and Wyoming. A hotspot is a portion of the Earth's surface which experiences volcanism. This may be caused by a rising mantle plume or some other causes. A volcanic hotspot is where lava pushes up from under the mantle and creates a volcano. The Earth's plates move along and another volcano is created later. The Yellowstone caldera has geysers caused by a constant geothermal energy activity, and the floor of the crater moves up and down as much as 50 meters in a few years. It created the eastern Snake River Plain through a succession of caldera-forming eruptions. The resulting calderas include the Island Park caldera, the Henry's Fork caldera, and the Bruneau Jar Bridge caldera. The hotspot currently lies under the Yellowstone caldera. The hotspot's most recent supereruption, known as the Lava Creek eruption, took place 640,000 years ago and created the Lava Creek Tuff and the Yellowstone caldera.
Basalt is an aphanetic igneous rock that is mafic in composition and forms extrusively. The basalt distributed throughout the Owyhee Volcanics formed during the Miocene epoch. Rhyolite is an igneous volcanic rock of felsic composition. It can have a glassy to aphanetic to porphyritic texture. The rhyolite distributed throughout the Owyhee Volcanics formed 8 to 14 million years ago during the Pliocene-Miocene epoch. Tuff is an igneous rock formed from the products of a pyroclastic volcanic eruption. The tuff distributed through the Owyhee Volcanics formed 10.3 to 12.7 million years ago.
The Bruneau sand dunes are located 8 miles east-northeast of Bruneau and 18 miles south of Mountain Home. These dunes were formed from constant wind activity and a natural trap. Unlike most, these dunes do not drift as the winds blow from 2 different directions, keeping the sand relatively in the same place.
The China Hat Dome, composed primarily of rhyolite, is a geologically young landmark near Soda Springs in the Blackfoot lava field. It stands nearly 1,000 feet high and is 1.4 miles long. It formed during a small rhyolite eruption only about 57,000 years ago, and is the largest of 3 domes lined up above a buried fissure that fed magma to the surface. The rhyolite magma was so viscous it couldn't flow away from the vent, it just accumulated into a pile. Since the volcanic activity in the Blackfoot lava field was so recent, the area is of considerable interest to the geothermal energy. Domes similar to the China Hat are a common type of volcanic landform that are built where small batches of viscous magma erupt. Looking at the balanced rock made of rhyolite, there are many rhyolite lava flows like the 8 million year old balanced rock flow near the Castleford with the Snake River Plain and Hawaii Plateau. Most are younger than the huge welded tuff layers, but are older than most of the basalt flows. These lavas form from rhyolite magmas with very low gas contents and just ooze out of the earth rather than erupting explosively. Low gas contents make rhyolite magmas very viscous, so that form flows that may be hundreds of feet thick and take years to cool. As they cool, prominent vertical fractures from in their interiors, which, when exposed in canyon walls, typically guide the development of large vertical pillars. Buck Mountain Volcano was formed about 11.6 million years ago. And this small rhyolite volcano in the Owyhee Mountains south of Homedale was built during one of the eruptions that led to the formation of the Jump Creek rhyolite. In this view, one is looking into the volcano's crater area. A small rhyolite lava flow was extruded from the volcano, whereas the volcano's slopes are an accumulation of small blobs of splatter that merged into the original narrowed form. When only small volumes of rhyolitic magma are erupted, small volcanoes like Buck Mountain are built, whereas large volumes of rhyolitic magma typically erupt through the long fissures along with the surface subsides to form calderas.
At the Black Rock Escarpment, there are several welded tuff layers that are magnificently exposed in this 1,500-foot high cliff in the Bruno Canyon near the Nevada border. Each layer is rhyolite that erupted explosively in the Bruno-Jarbidge region in an early active portion of the Yellowstone hotspot. The layers range from 12.7 million years old at the base of the sequence to 10.3 million at the top. They make up the Cougar Point Tuff, a volcanic unit widely distributed along the margins of the central Snake River Plain. In a geologic instant, some of these enormous explosions erupted many hundred cubic miles of rhyolite magma as tiny molten particles that sped across the land buoyed up by hot gases, blanketing areas more than 100 miles across. Welded tuff layers like these are believed to lie beneath much of the Snake River Plain and the Owyhee Plateau.
Formation of this area suggests that there have been plate movement, volcanism, and glacial changes that have all contributed to the glacial changes these areas have undergone. The North American Plate moved over a hotspot that is currently located beneath Yellowstone National Park. The North American Plate still moves approximately 4.5 millimeters a year over this hotspot. This activity happened about 17 million years ago and continues today. Tuff deposits near the Snake River Plain record the path of movement. There are many basaltic lava fields and rhyolite domes that overlie the hotspot. Many of these basalts erupted along volcanic rift zones that are oriented parallel to the direction of the regional basin and range extension. As the plate migrated to the southeast and volcanic activity shifted to the new regions, the extinct calderas gradually subsided to their present elevations due to the thermal and gravitational effects. As the Continental Divide moved eastward across southern Idaho, rivers south of the Snake River Plain began to flow south and east. Subsidence in the wake of the hotspot migration caused a drop in the base level of the Snake River Plain, which initiated headward erosion toward the modern Snake River Channel. This eventually led to a stream capture and the shift of drainage to the Pacific Ocean. In the Pleistocene, Idaho was a cooler, wetter place. Trees grew on the Snake River Plain during maximum glacial cool intervals about 140,000 and 20,000 years ago. When the glaciers melted, constrictions in the canyons produced local dams and periodic floods on the Snake River, Columbia River, and Big Lost River systems. Idaho was influenced by both climatic effects of the Rocky Mountains and Yellowstone area on the east and Pacific Northwest climate on the north and west.
Idaho has the potential to provide all the electricity used in the state. Idaho could install 18,000 megawatts of wind power capable of generating 52 billion kilowatt hours a year. Owyhee is home to the famous Owyhee Mining District. Gold was first discovered here in 1863. One city, Silver City, at one time had as many as 250 mines active in the area. Today, Silver City serves as a historical district. Geothermal energy uses the heat from inside the earth to heat water. Geothermal hot water is used to heat buildings, raise plants in greenhouses, dry out fish and crops, de-ice roads, and improve oil recovery. Geothermal energy has been used in Boise, Idaho to heat homes and buildings for over a century. There is plenty of heat found in Owyhee Volcanics from the movement of the Yellowstone hotspot.